So in this question, we've got a skydiver drops from rest from a hot air balloon and falls vertically under gravity for 5 seconds before his parachute opens. Of course, then when his parachute opens, right, his speed is going to reduce, isn't it? Because he's not going to fall so fast because there's so much air resistance now. His parachute's slowing him down, yeah? And he slows his speed down to 4 meters per second, it says there. Okay. And then he continues to travel at this constant speed for 4 seconds until he reaches the ground 2 minutes after he left the hot air balloon. Okay, so part A, calculate the speed of the skydiver just before his parachute opens. Now if we think about this parachutist, right, he's jumping from the balloon, okay, from rest, right, so he drops basically, yeah, so he drops from it, lets himself go, so the initial speed will be 0, yeah, when he drops from this balloon, right, but he's going downwards, isn't he? So if you think about it, his direction is downwards, so we take downwards as positive, and if we take downwards as positive, we must remember, of course, that's the same direction as gravity, okay, so the acceleration is going to be positive 9.8, isn't it? In other words, it's going to speed him up. Okay, right, because he's falling in the direction of gravity, right, as you would, but be taken downwards as positive because that's where he's going initially, dropping. And it says that he falls under gravity for 5 seconds, so t is equal to 5. And part A then, it says calculate the speed of the skydiver just before his chute opens. So basically, in these 5 seconds, he's really increased his speed, hasn't he? Okay. And then his parachute opens. So we can work out V by using V equals U plus AT. So V then will be 0 for U and then plus 9.8 times then time, which is 5, and then that comes to be 49 meters per second. So that's the speed he's got to, right? He's going really fast. His chute opens and his speed starts to fall straight away. Okay? So part B then, it says draw a velocity time graph to just show the whole descent here, okay, as he's falling. So with a velocity time graph, remember you need to label the axes, velocity, and then of course the units, meters per second, right, and then the horizontal axis, of course, is going to be your time, which is measured in seconds. Okay, so make sure you have that all labeled there. And on your origin there, of course. Now he starts from 0, doesn't he? Okay, starts from nothing. Velocity is 0, starts from rest. And he falls under gravity for 5 seconds. But when you fall under gravity, okay, that acceleration, 9.8, okay, will give us quite a steep gradient, won't it? Because remember, the gradient is the acceleration. So I'm thinking maybe a gradient this steep, okay, right? Make it quite steep because, as I said, 9.8 is my gradient due to acceleration caused by gravity. And that all happens in a 5 second period. Okay, and it gets into a speed of 49. Okay. Now he opens his chute and then, of course, straight away his speed's going to reduce, right? From opening this chute. And it says for a further 10 seconds, okay, he uniform retardation. In other words, he decelerates for 10 seconds, okay? So if he's first 5 seconds there, another 10 seconds will take me to about there, and he reduces his speed then quite quickly because of this parachute, and it reduces it to 4 meters per second. So 4 is going to say be there, okay? So we need to join up that there to show he's reducing his speed, the uniform retardation, and it takes him 10 seconds to do that. Okay, and now he's traveling at a speed of 4 meters per second, and he says he continues to travel at a constant speed of 4 meters per second until he reaches the ground 2 minutes after he left the hot air balloon. So 2 minutes, he just keeps going then at that speed of 4 meters per second, so a straight, flat, horizontal line. He reaches the ground 2 minutes after he left the hot air balloon. So after he left the hot air balloon would include this time, so 2 minutes in total here, which of course is 120 seconds. Okay. The part C then, it says determine the height of the skydiver above the ground when he drops from the hot air balloon. So the height of him above the ground when he drops from the hot air balloon. Now we're going to need to use this to work out the height. Okay, we can't just do it using equations. Okay, we can't just use equations because there's 3 stages of the journey. We could use equations, but we'd have to do it for the 3 stages, as I said, because here he's accelerating, here he's decelerating, and then here he's going at a constant speed. So you have to use the equations 3 times. But why are we going to do that when we've got a velocity time graph and we know the area under the graph is quite simply equal to the distance travelled, yeah? Or in this case, the whole distance of the journey, the distance fallen. Okay? So what I'm going to do to work out the area here, I'm going to split this up, as I said, into 3 parts. I'll perhaps emphasize that here by drawing lines here. So if I call this my shape A, you could see then that's a triangle, can't you? So area of A, triangle, so that's half times base, which is 5, times the height, which is 49. So if I do that on my calculator, I get 122.5 meters. B then is the next part of the journey. Now that shape there, think about what that shape is. It's obviously a trapezium, isn't it? Trapezium, half again. With the trapezium then, you've got the 2 sides that are parallel to these 2 sides. We need to add them together. So you've got 49 this side, added then to 4 this side. And then of course you've got to times it, with the trapezium rule, then you times it by the height between them, which is 10. Okay, so if you do that, I get 265 meters. Okay. And then area C then would be this one. And that's quite simple because that is just a rectangle. So the length is 105 and that width then, or the height, is 4. So that's easy to do, isn't it? 420 meters. So to get the total distance then, what I need to do, of course, to get total distance 4 then is to add those 3 parts of the journey together. And I get a total answer then, if I've done this right, of 807.5 meters. That's how much he's fallen.